Welcome to the second installment of the Professional Amateur Chemist series. You may have noticed that the first video did not have reactions and math work. To tell you the truth, I didn't know what I was going to do for a video. This video, however, and future videos will have increasingly better content. Now that we have that out of the way, we will be synthesizing copper chloride today, which is not as easy to make as the ammonium chloride in our previous video. We will need to take a 3-step process to get to it. As copper does not react with hydrochloric acid, we'll have to make a salt that does. Copper 2 chloride is a chemical compound with the formula CuCl2. It slowly absorbs moisture to form a blue-green dihydrate, otherwise it is a light brown solid in its anhydrous state. The copper chlorides are some of the most common copper compounds after copper sulfate. Copper 2 chloride can be prepared by chlorinating copper, but we will be preparing it by reacting copper carbonate with hydrochloric acid. We will be needing the following items for this synthesis: 250 grams of copper sulfate, 106 grams of sodium carbonate, 400 milliliters of 32% hydrochloric acid, 100 milliliters of ethyl acetate, 100 milliliters of acetone, 500 milliliters of distilled water, 2 500 milliliter beakers, stir plate, 250 milliliter separation funnel, and finally, filtration. To begin the synthesis, we are going to create copper carbonate by reacting copper sulfate and sodium carbonate. To do this, I'm going to hand you over to my capable assistant.
Today, I will be showing you the synthesis of copper carbonate from copper sulfate in this segment. First of all, we take our 500 milliliter beaker and place it on our stir plate. We add 200 milliliters of the distilled water to the beaker, add the sample of copper sulfate, and dissolve it into solution. Copper sulfate exists as a pentahydrate, so 90 grams of the copper sulfate is water. So to figure out yield, we need to take that into account. Next we take the sample of sodium carbonate, and slowly add it to the copper sulfate solution. The copper carbonate salt that follows will completely precipitate out of solution, as copper carbonate is completely insoluble in water. The reaction and stoichiometry are as follows. Rounding off to whole numbers for ease of our reactions. There is approximately 250 grams in 1 mole of copper sulfate, and 106 grams of sodium carbonate in 1 mole. But we must remember that 90 grams of the 250 grams of copper sulfate is water, so if we subtract that from our amount, we get 160 grams of copper sulfate. So if we look at our reaction, it takes 1 mole of copper sulfate to react with 1 mole of sodium carbonate. So if we look at the reaction, it yields 123 grams of copper carbonate. To finish our synthesis of copper carbonate, we let it sit until it has settled, and then we decant off the water layer, and then filter and wash with acetone to get rid of any unreacted salts, and help drive off water for drying. After you recover your copper carbonate from your filter paper, and you let it dry, you can powder it, and get it ready for the next step. Thank you, and back to you, Professor.
Thank you, that was a very good job. Now that we have our copper carbonate, we can continue on to the copper chloride reaction. We take our sample of copper carbonate and place it in the other 500 milliliter beaker we have, and we slowly add a stoichiometric amount of the acid, depending on your yield of copper carbonate. You can figure this by finding out your percent yield. Our figured theoretical yield was 123 grams, so if you have less than that, divide what you got by 123 and that will give you your percent. Take that percent and multiply the difference against our 400 milliliters of acid, and that will give you your stoichiometric amount. Now that we have our acid amount figured out, we can add it slowly to the copper carbonate. If you have your SEP funnel, now would be a good time to use it. Set it up and begin stirring and adding your acid slowly, as it will give off gas and may bubble over if you do it too quickly. After all of your acid is used up, continue stirring until it no longer bubbles. Then to separate it, you heat it to boil and reduce it down to almost no water remaining. If you want at this point, you can do two things. You can continue heating and stirring to dry it. Then when it's nearly dry, take it off heat and dry it. Or if you are impatient, you can add an equal volume of ethyl acetate to the mix to precipitate out 2/3 of the crystal present. Then decant off the liquid. You will lose 1/3 of the yield to the acetate unless you evaporate it off to dry, then you can recover the remaining product. Use this method only if you need some product immediately. Take your samples after they are dry completely and container them for future use. To review what we did today. We reacted 250 grams of copper sulfate with 106 grams of sodium carbonate to yield 123 grams of copper carbonate. We then reacted the copper carbonate with 400 milliliters of 32% hydrochloric acid to yield 134 grams of copper chloride. We have shown you how to synthesize copper chloride. We will be using this in the future to do other projects that call for it. If you have a desiccation chamber, you can use it to dry your sample further. I will show you in the future how to make one. If you have any further questions about this video, any other videos, or copper chloride, you can contact me or your local library.